We have homogeneous functions. Now, in differential equations, we have this main format. We have m of xy dy plus n of xy dx is equivalent to 0. Now, in homogeneous functions, we usually follow this format to solve differential equations. Now, what is this homogeneous functions? Now, to explain these homogeneous functions, we will make some examples of polynomials. So, we have x squared minus 3xy plus 4y squared. Another polynomials, we have x cubed plus y cubed, and also x to the fourth y plus 7y to the fifth. If you observe these polynomials, the exponent of x is 2. For this part, 3x raised to 1 and then y raised to 1. If you add the exponent of x raised to 1 and y raised to 1, that is all in all 2. For this case, you have 4y raised to 2. If you have noticed, if you look at the degree for each polynomial or for each term of a polynomial, the degree of these terms is 2. These terms, the degree is 2. And then the degree of this term is equal to 2. For this example, we have here x raised to 3, y raised to 3. So the degree of x is 3. The degree of this term is also 3. So they have the same degree. For this case, you have here x to the fourth, y raised to 1. So if you add the exponent, that becomes 5. Therefore, the degree here is 5. For this term, the degree is also 5. So, when polynomials in which all terms are of the same degree, okay, all terms, we say all terms of same degree are called homogeneous functions. So this is how we describe a homogeneous functions. Polynomials, the terms of a polynomials have the same degree. So that is homogeneous function. To solve homogeneous function in differential equation, we will use substitution method. And then we will be using, let's say, y is equal to vx or x is equal to vy. So we will be using this variable to substitute in a differential equation. Now, when can we use y equals bx or x equals vy? If you want to, you have to identify from your main format of differential equation, if you think that this part, the part of dy is complicated, so you will be using x equals by if this is complicated. In other words, if this is complicated and then this part is not complicated, so you will be using let x equals by. However, if this part is complicated with your dx and then you have your y, dy is more simpler, so you can make use of y equals bx. To understand the methods of solving differential equations to homogeneous functions, we will have an example. So first example, we have solved the equation x squared minus xy plus y squared dx minus xy dx is equal to 0. So we have this one. By the way, this is dy. Okay. So xy dy. If you have noticed, this is homogeneous function. The terms here, I mean the degree of the term here is 2. This one is 2. This one is also 2. And then this one is also 2. Therefore, this is a homogeneous function. So in a homogeneous function, we will be using substitution method. Now, to use substitution method, in your mdx and dy, you have to identify which of your mdx or ndy is, let's say, simpler. If you notice this one, ndx plus this part is simpler. Okay, xy dy. So if this is simpler, we will use let the substitution as let y equals vx. So since dy is simpler compared to dx, so we will be using this one, let y equals vx for our substitution. So if we have y equals vx, then dy, the derivative of y, dy equals derivative of vx equals v dx plus x dv. So this vx is the derivative of uv. So v dx plus x dv. This time, we will substitute all values of y by vx and dy by v dx plus x dv. Okay, so we will now start our substitution. So this is x squared. So I will write here x squared. And then minus x. Instead of writing y, substitute it as vx. Vx. Okay. And then plus y squared. So instead of writing y, I will make use of vx. So that is v squared x squared. V squared x squared. And then dx minus x and then y, that is equivalent to vx, and then we have dy, which is equivalent to vx plus x dv. V dx plus x dv. This is now our dy, which is equivalent to 0. So this time, this is equivalent to x squared minus this one is x. Okay, I will write here minus v x squared plus v squared x squared dx. Okay, dx. And then this one is, I will distribute this one, x times bx, that is vx squared times b, that becomes negative v squared x squared. So negative v squared x squared dx. So I will distribute this one to v dx and also distribute this one to x dv. So when we distribute this one to x dv, that becomes xx x squared x cubed minus v x cubed dv. That is equivalent to 0. So when we distribute this one, that becomes x squared dx. Okay, I will combine this group minus v x squared dx. So I'm supposed to distribute dx to x squared, dx to vx squared. So we have this one. I am combining this one. And then I will separate this v squared x squared because I have here negative v squared x squared. In other words, this will be cancelled. So we have here plus v squared x squared dx minus v squared x squared dx for this case. So this will be cancelled. And then minus v x cubed dv, which is equivalent to 0. Now, this time, all x are combined with dx, and all v are combined with dv. So for this case, you have x, I will factor out x squared. So x squared times 1 minus v. We have dx. So factoring x squared, so x squared 1 minus v dx. And then minus this one, you have here minus v x cubed dv is equivalent to 0. Now, by transposition, okay, so this will become x squared and then over x cubed. So what remains on this side is dx over x. Okay, I will write first x squared dx over x cubed. And then on in dv, you have here v over 1 minus v dv, which is equivalent to 0. So this part is dx over x. Dx over x. And then this part, of course, we have to divide this one. So when we divide, that is, let's say, v, I will write here the division of v. We have negative v plus 1. So v divided by negative v equals negative 1. Negative 1 times negative v, that is equivalent to, okay, I will just, sige, negative 1 times negative v equals positive v. Negative 1 times 1 equals negative 1. When we subtract this one, you have here a remainder of positive 1. Therefore, we have to write minus, for this case, that is minus 1 plus 1 over 1 minus v dv equals 0. So this time, we will integrate both sides. We have here integrate. We will integrate this one minus, and then we will write our integration to 0. So that when we integrate this dx over x, that is ln of x. And then dv times 1 integral of dv, that is negative v. And then this one, the integral of dv over 1 minus v, let u equals 1 minus v. The derivative of 1 minus v is equivalent to negative dv. So negative times negative, that becomes positive. So we have here positive ln of 1 minus v. So this is ln. And of course, instead of writing c for this case, we will write ln c because it appears here that we have ln. So we will write here ln of c. So we have ln of x minus v and then plus ln of 1 minus v. Okay. So by the way, this is negative 1, so this is supposed to be negative 1 times negative. This becomes positive. sorry. So I will write here negative 1. Sorry, so this is negative 1. This is negative 1 plus 1 over 1 minus v. So negative 1. So that when we integrate, negative 1 times negative 1 is positive 1. And then we integrate dv. So this is now positive. So ln of x plus v plus ln of 1 minus v equals ln of c. Now when we combine this 2ln, the result will be, I will write here a line. Okay. So this is now equivalent to v plus ln of x times 1 minus v. We will combine these two ln, which is equivalent to ln of c. Now this ln of x1 minus v, if we want to transfer this one to the other side, that becomes minus. Therefore, if that is minus, so you will have here v is equivalent to ln of c over x times 1 minus v. Okay, c. For this case, we have here ln of c minus ln of this group. Let's say I will draw a line here. So if this is okay, I will write first. Let's have this one. Ln of, let's say, a minus ln of b, that is equivalent to ln of a over b. So this is what happened to this part. And then if we want to transfer ln to the other side, okay, or by transposition, our equivalent now is e raised to v is equal to, we have c, and then I will, okay, c over x1 minus v. And then transfer this one to the other side, that becomes e v x1 minus v equals c. Okay, so this time we arrive now our equivalent of c, which is e raised to b x1 minus v. Okay, so we go back to our substitution wherein y equals bx. Therefore, since this is v, we will transpose x to the other side so that v equals 1 y over x. Y over x, that is our equivalent of v. So this time, substitute the value of v as y over x. So this is e and then y over x. Okay, v equals y over x. And then x and 1 minus, instead of writing v, we have here y over x equals c. So our final answer now is we have c. So okay, so I will just move this one, c. Okay, let me reduce my writings. Okay, I will reduce my writings. I have this limited space only, so we have e raised to y over x, and then x times 1 minus y over x. That is equivalent to, okay, I will write this one in a clear, okay, y over x. So I will write this one clearly. So I think this is already clear. And then equals c. So that when we have our final answer, we have e y over x. And then we have x times 1 that becomes x minus y all over x. But, so for this case, I will write x minus y all over x. For this part, if I will combine 1 minus y over x. So, x times 1, that becomes x minus y all over x. And if you have here a multiplier of x, so this x will be cancelled. So, what remains here is x minus y. X minus y, that is equivalent to C. So, this is our final answer. We have e raised to y over x times x minus y is equal to C.